Hello class, and welcome back with Mrs. Struble. Today we're going to be talking a bit about inequalities. Now, just a reminder, inequalities are symbols that we use to compare values. So they're value comparison statements is what we use them for. So these are the four main symbols of inequalities. We have less than or equal to, greater than or equal to. And that's how we read them, and that's what we identify them to be. Okay. Just make a quick note here. And we're going to have this down below here, but it's always good to recall which one's less than, which one's greater than. First thing we're going to discuss is how we write inequalities, inequality statements from word form. Okay. So writing inequalities, we look for keywords. We have the four different inequalities, but we must know what keywords we're looking for each one. For example, if I want a number that is less than something, I'm looking for one that's under it or it's fewer than it is. Okay, so we would use the less than symbol there. Whereas this number I'm looking for needs to be less than 5 maybe. Okay. Over here in the next one, we have the less than or equal to. Less than or equal to could also be called at most, or no greater than, no more than, and even maximum, even though that seems kind of odd. If I say I want a maximum of something, that means I want that much, no more. Okay, but I'm okay with having less. All right. Another key word for less than or equal to is not exceeding. Okay, we do not want whatever we're discussing to be over the amount given. Okay? And that this one works more with dealing with money situations where I have a certain amount of money and I cannot spend any more than that amount. Okay, so my total cost cannot exceed the amount that I have. All right, moving on to the next one here, we have the greater than symbol. Other words that can mean greater than or more than, exceeds, above, larger than, pretty much any synonym for greater than will work. Okay. Same thing with the greater than or equal to, pretty much any synonym that means greater, you could just tack that in greater's place, and we could have more than or equal to, we could have larger than or equal to, okay? All the synonyms work here. But we also have the word minimum, okay? I want a minimum of something, which means I want that much or more. I cannot or I do not want less. Other keywords for greater than or equal to are at least or no less than. Okay. And keep in mind you can pause this at any time if I'm moving a little too fast for you, and re-listen to it as you need to. Let's take a look at how this would. Let's take a look at an example and how this might look on paper form. Okay. So if I have a statement, a number q plus 5 is less than or equal to negative 7.9. And I want to write this word sentence as an inequality statement. Well, the first thing I'm going to do is identify my variable. Okay. Sometimes that's easy to spot, other times not so much. In this case, it gives us flat out what our variable is. It's our unknown. So a number, q is our variable in this case. Okay. Oops, and I'm going to go ahead and underline that. The second thing we need to identify is what other values we have in the statement. Okay, and I'm going to put other essential values because sometimes they'll give us more than what we need in a problem, and we need to determine, is that essential to what I'm trying to do or not? So other essential values in this case would be 5 and negative 7.9. Right? Lastly, that's when we identify keywords. Or statements, phrases, okay, that tell us a little bit about what we're doing in this inequality, whether we're adding, subtracting, multiplying, dividing along the way, and which inequality we're using. So some of the words that I see here are math keyword of plus, literally means to add, okay? And then we have less than or equal to, is less than or equal to. Now you'll often see the is in front of the inequality keyword, okay? And that just tells you that that's the end of one's value leading into how it compares to another. Next thing we do is really, we just put it all together. So plus means to add, less than or equal to, that's this symbol, okay? So putting it all together, we have Q plus 5 is less than or equal to negative 7.9. And that's it. That is our inequality statement. Okay? We'll work towards solving this and what it looks like that later at a later date. But for right now, I just want you to see how you can write one. Okay? So down below here, I've got a couple of try-its. I want you to go ahead and pause the video and try the problems. Now that you've paused the video and tried them out, let's see what you got. For number 1, you should have gotten x as your variable. Your essential number is negative 10, or numbers in this case, or in some cases. And then our keywords is at least. Okay? Throwing it all together is x. Now at least, hopefully you use this because that's one that gets a lot of us. At least is actually the greater than or equal to sign. Okay, greater than or equal to negative 10. Now I'm going to reread the statement, making sure that it makes sense to me. Okay? Is x at least negative 10? So if x is 10, it's greater than negative 10, right? Is 10 at least negative 10? And yeah, definitely. Okay? It's more than it, but it at least covers that more than basis. Doing the same thing with the second one. Twice is a dual action word, is kind of what I like to say. It's a number, but it also has a key operation in with it. Okay, our variable is y, and we have negative 5 halves. And then we have is more than as another keyword. Okay, so twice is a dual action word. Here's why. It means 2 times. Okay, so we have 2 times y. In algebra, we just write those two together. Is more than. So this right here is more than the negative 5 halves. And we can go ahead and put negative 5 halves while we're figuring out which inequality to use. Is more than. This is more than negative 5 halves, so that's the greater than symbol. Or for now, let's make sure we're double checking using our notes. Yep, you bet. Okay. Right. Next thing we're going to discuss about inequalities is how might we use our knowledge of inequalities to check possible solutions or solution sets. Now, inequalities have multiple possibilities, sometimes infinitely many answers. We use what's called a solution set to represent all of the possible answers. So we're going to start off basic on these, not using a solution set at all, but keep that in mind. So if I say a solution set of something is this, that means 2 and any integer less than 2 satisfies whatever I'm talking about. Okay? And there's multiple ways that we can represent a solution sets as we go throughout our math career here. All right, here we go. Let's do an example real quick. So these are pretty basic. Hey, I'm going to give you a value, and you're going to see, does this make the inequality statement true or false? In other words, is this a possible answer for the variable? Okay. Literally, it's just a matter of substituting in and solving and seeing if it holds true. So here I substituted -2 in for y, and we have -2 minus 5. Well, -2 minus 5 is -7. And I need to ask myself, is -7 greater than or equal to -6? Well, the answer to that is no, it's not. Okay? So that would be a false statement. -2 is not a solution. Right? And leading into the next one, again with the -2, we're going to substitute that in. They're asking, hey, does -2 work here? It did not work in the first one. Let's see if it works in the second one. Substituting it in, when I have a number next to a variable, remember that number is called the coefficient. That means multiplication. So we're going to take -5.5 or -5 and 5/10 and multiply it by -2 and see if we still have, see if we have a correct answer, or a true statement rather. Okay. So taking -5 and 5/10 times 2, -2, negative times the negative, we know is going to be a positive. Okay? And we actually end up getting 11. 11 is less than 14, so yes, this is a true statement, and -2 is a possible solution. Okay? Let's go ahead and have you try a couple. All right. Let's go ahead and try these. Now I want you to see if -5 is a solution for any of the following inequalities. In this case, it doesn't matter which side of the inequality variable the variable is on, as long as the inequality statement is still true as soon as you substitute and simplify each side. Try them, pause the video, and I'll be back with the answers. Now that you've went ahead and tried these, let's go over what you get. Okay, for number 1, as soon as you substitute, you have that 1 is less than or equal to 3, which is true. So yes, that is a solution there. In the second one, when you substitute -5 for p, you end up with 6 is greater than -5 halves. Well, -5 halves is equivalent to 2.5. So, but we always have a positive that's greater than a negative. So yeah, that's definitely true as well. And -5 is a solution for this inequality. As far as the last one goes, we end up getting that -7 is less than -9 after substituting. The greater the negative, I have this little phrase to help us remember. The greater the negative, the smaller the number. In other words, -9 is 2 under -7. So it's actually smaller than -7, not greater than, as this would suggest. So no, in this case, -5 is not a solution of this inequality. Lastly, we're going to talk about graphing these inequalities, what it looks like to represent all possible solutions of these inequality statements. Okay? And each inequality is going to look different. Now, when we have an inequality statement that we want to graph, we end up with some value or a variable, in most cases, is going to be compared to a number. Okay? So what we need to do is on our number line, we're going to go to that number that we know for a fact is a part of that solution. And then we start from there. So I have my number, and if my missing variable is less than that number, which direction on the number line can I go to remain true? And the answer in this case is to the left. So all of my lower numbers are going to be to the left no matter what number I start out with. Now comes the next question though. Can I be equal to this number? In other words, can I put a solid dot as if I'm representing an integer on this particular number line? And the answer is no. Okay? This number is not included in this inequality. So when I graph it, I'm going to have that open area, and then it's going to go to the left. Okay? All right. For the next one, kind of the same thing. The only difference here is, yes, that variable can be, or that number can be included this time. Okay, so the variable can equal the number that I'm starting with. All right, so that's the less than or equal to graph and what it looks like. Again, assuming this is when our variable is on the left-hand side, whether we're talking about x, w, maybe we're talking about a, whatever that variable is, this is assuming that variable is on the left-hand side of the inequality statement. Let's do C. All right, here we go. Greater than. If I have a missing number that's greater than another number, it cannot be equal to it, and the greater than is always to the right. Okay, so the bigger numbers are always to the right of a number line, so that's where we need to graph. So we use a solid arrow to represent that it can be literally anything on the number line. I can have this be 5, and my missing value is 5.01. Okay, well, that's still greater than 5, but it's not equal to 5. So it still passes as a possible solution. There's literally infinitely many solutions. All right, last but not least, greater than or equal to. Again, we're dealing with greater than, so we know it's going to go this way, but we also can be equal to this number, whatever this number is. So we're going to have that open circle right here. Okay. We're basically just saying that, hey, don't touch that number. You cannot have that number. Right? But you can have anything. Oops, sorry, this is greater than or equal to. Where am I thinking? There you go. All right. So yes, it can be that number in this case. I had to double look at the sign here. All right. Let's use a real world example to see how this might look on a graph. All right. So here we have to write and graph an inequality. So rock climber's sleeping bag is recommended for temperatures no less than -15 degrees Celsius. Now, when you're going rock climbing, that's pretty important to understand and know. So what does that necessarily mean? Can I go out in wintertime or not? Okay. No less than. All right. So we're dealing with temperatures. Temperatures is going to be our variable. So remember, number 1 is to identify the variable. In this case, It's the temperature. Okay, so we can use T for temperature. Now we have to identify any extra or essential values. And in this case, negative 15 degrees Celsius is an essential value. We're literally comparing the sleeping bag temperature, or the temperature that the sleeping bag is recommended in, to the negative 15 degrees. All right. Now we have the word no less than. Well, the temperature, using this symbol, it says the temperature is less than negative 15. But that says no, it cannot be less than. It needs to be greater than. The trick here is, well, can it be equal to? And to answer that, we just basically ask ourselves, well, if I have negative 15, is negative 15 no less than negative 15? And the answer is yeah, it's fine. Okay, so the temperature outside needs to be greater than or equal to negative 15, no less than it. So negative 20 is a no-go, and it's not recommended to use this sleeping bag safely. So what does the graph look like? If I have a graph, the number I know for a fact is the negative 15 degrees. What values could I have and be okay in this sleeping bag? Well, we just determined we can have negative 15, but we can also have any temperature greater than that negative 15. So that's what your graph will look like. All right. Last thing, just a little tidbit. I spoke a little bit up the top here, making sure you understood that, hey, the variable, this graph looks this way as long as the variable is on the left-hand side. But what if it's not? Okay. What if I have literally 5 is less than x? What does the graph look like then? And how do I know? Well, remember when we're graphing, we're representing the variable, all its possibilities. So let's think of some numbers. Can it be equal to 5? No. All right. What about 4? Is 5 less than 4? And the answer is no. Okay, let's go the other direction. What about 6? 5 is less than 6. So yes, it can be equal to 6. So how do I represent all possible answers, knowing that 6 is also a solution in the solution set? We're going to start with our for sure fire number. Okay. We know it cannot be equal to 5, so it's going to be an open circle, but x can equal 6, and that means it's going to go to the right. Okay. In other words, we're reading this inequality backwards. Okay. The graph represents the variable. So we start with the variable x, and then we read it this way. Now, x is not the less than one. X is actually the greater than, noticing that it opens up. So we would read this, x is greater than 5, assuming we wanted to read it backwards, or x first. Okay? And that is how we graph it, with the variable first. So essentially it just flips, is one way people think of it. Okay, so everything just flips. The variable goes to the other side, the number goes to the other side, and even the inequality statement flips around. Now, if you have a less than or equal to symbol, it just flips to the greater than or equal to symbol. Okay, so these are equivalent statements, these two right here. A is the greater than 1 on both of these. Okay? All right. So in this video, we covered a lot. We covered about writing and graphing inequalities, what to do when we see different keywords, what they mean, and how to determine whether a solution is creating a true inequality statement or not. Okay. Thank you for joining me, and I'll see you next time.